Okay, so hi, my name's Alec. I work here at Agape Red. To be 100% honest with you, I kind of threw this together way more last minute than I should, but the good news is I've been working on the project for a while, and I think I'm sufficiently passionate that I can ramble about this for a while. So you'll have to stop me when that happens. So Meta.js, I think, will become more clear as I start talking about problems it's meant to solve. So Meta.js is a library I've been working on. It's a combination of a runtime library and a transpiler that makes some assumptions about the type of code you're writing in order to add features to the language that, in my opinion, are missing. So specifically, it requires you to use static scoping. But you're probably already doing that anyway, unless you're using the with keyword, eval, or the names of functions. If you're using like the function.name, unless you're changing that or messing with that, your scope is already static, so you're good to go. In general, if your code minifies, it's already static because the minification process relies on the same fact. So not a huge demand being put on code. So the big problem that kind of inspired this whole thing, I'll try to briefly illustrate, but it comes down to garbage collection problems inside of JavaScript when you start writing large applications. I'll give a specific example. So you have a collection that maybe comes back from the server, and a collection, in Backbone, it doesn't have to be tied to a specific library. This is kind of a general problem. But a collection has models inside of it, and so there's a strong. So the arrows represent strong references. The bidirectional arrows represent strong references in either direction. I should probably talk about what that is. A strong reference is basically just a reference. So the JavaScript garbage collector works by going through what it calls. So it starts with the global scope, and it looks at all of the everything that's in the global scope, and it looks at what those things reference and works its way out. So basically, it marks every object. In the simplest implementation, it marks every object to be removed from memory. It starts with the global scope, and it works its way outward and marks to keep them. And so then everything that is, in theory, no longer referenceable gets removed. So pretty simple. Because of the way JavaScript is set up, it turns out to be a little bit simpler than it is in other languages. There's not a lot of the scoping is really predictable in JavaScript, especially when it's statically scoped. But that's the general idea for how it works. So a collection object will have strong references to its entries. So I put a model. So there could be multiple of them, but only one is required for this example. And a model will have a strong reference back to the collection in a lot of cases. So JavaScript is obviously an event-driven language, so a lot of times you're listening for an event to happen. And this is why we need a weak reference. But basically, there's no way to listen to an event. You can only ever ask something to let you know when something happens. And when you ask another object to let you know when something happens, it has to hold a strong reference to you so that it can tell you about it later. So anytime you're listening to an event, you're guaranteeing that you won't be garbage collected until the other thing is garbage collected that you're listening to. Doesn't sound that bad. But what happens is you have a collection, you have a strong link between the collection and the model, and then the model back to the collection, because if the model is destroyed, it needs to remove itself from the collection. So that's pretty simple. Nothing's wrong here so far, because if the model and the collection both become no longer referenceable by other means, the fact that they have a circular reference turns out to not matter, because it's smart enough to go from the global scope and go, okay, I can't get to either one of these, so they can both be removed. It doesn't matter if they reference each other, as long as they both can't be referenced anymore from the global scope or from a closure of a function inside of the global scope. So a collection will probably be associated with a list view, maybe a list of things, and so you then have the list view listening to the collection, which means it's holding a strong reference. The collection is holding a strong reference to the list view because it needs to tell the list view whenever it gets changed. And then conversely, the list view is probably holding a reference to the collection because that's just kind of standard practice. It's really convenient, and it needed to go to the collection to ask it to tell it when the collection changed, if that makes sense. So we kind of got that upper triangle going. And so then this list view will probably have list items inside of it. They could be items on a list, they could be edit views, it doesn't really matter, but the important thing is that this is probably like one view of an individual item in the collection. So that individual item will probably have a reference to its parent for one reason or another. And even if it doesn't, it'll have references to DOM nodes that ultimately have references back to the parent because of the way the DOM is set up if we're talking about views. And it'll also have a reference to the model. It'll be listening to the model in case it changes or in case something happens to it, so it can update accordingly. And so here's where the problem comes in. So the list item view may have a button on it, like a delete button. And this delete button will have maybe an event tied to it, like a click event. And that click event has a function that's a callback. And then inside of that function's closure, in order to be able to reference the list item to get to the model to tell it that it needs to be deleted, the callback has to have a strong reference to the list item. And again, there's nothing wrong with this so far. The problem is, so theoretically, at any given point, as long as you destroy all the global scope references to each of these things, they'll be collected and there won't be a problem. But what happens is that programmers aren't perfect. So every one of these events that's bound has to be unbound later in order for things to be garbage collected. So in Backbone, it's really, really easy to remove a parent view that's holding strong references to child views, that's listening to a model that's tied to a collection. And what ends up happening is you get zombie nodes in the DOM. So the delete button can't be garbage collected because even when a DOM node is detached from the tree, if it has events tied to it, it still won't be garbage collected because the DOM, well, it can't be, because it could be reattached later. The DOM doesn't know that you're completely done with the element. You could just be reattaching it somewhere else in the DOM tree, so it can't be garbage collected. And so if you call like remove on list view, unless there's some kind of custom user thing the programmer remembered to put in to go through and also call remove on all the list items, this delete button is going to end up holding a reference to a function which holds strong references to the list item, which, oh, look at that, holds strong references to everything else. So you end up with a situation where everything is still in memory and you can't talk about it anymore. So it's actually a really big problem. And so library writers have been trying to work around this, and the way that they do it is they add remove methods. It's like always call the remove method. Don't remove this with jQuery. Call the remove method. jQuery helps out with this a lot, although it does it in a somewhat inefficient way, which I guess I can talk about right now. So jQuery tries to combat at least part of this, at least the zombie node part, by doing something called an expando. So what it does is, and you can see this, so there's this jQuery.data thing, just on the root jQuery object, and it's basically just an object. In JavaScript, all objects are key value pairs, and so the key is usually a randomly generated alphanumeric string, and it randomly generates an alphanumeric string, puts it onto an object, and then it takes the key from the object, and it uses that inside of its data object. So the key from the object is associated with the map that's the data object, and then that goes to another object where it can store information about that node without actually putting the information on the node. And so what it puts inside of these things is it puts references, okay, which events were tied to which nodes. That way, later, when you remove the node, it can go through and it can go, okay, so it looks the whole DOM tree, it looks for expander properties on every node inside of it before it removes it, and it goes to its data object and it goes, okay, which one of these items had events bound to them, make sure I unbind them before I remove it, and that's the difference between remove and detach. But it turns out this has another problem, and that is that this data object then has a strong reference to the original function, right? Because it had to be a key value pair. So the DOM node has a string on it. You see what I mean? And then the string corresponds to that other object, which is holding strong references, and it can't remove it from the object because it needs to know about it when it removes the original DOM node. And so you're kind of back in the same situation. It's usually better because the data object just holds references to the jQuery callbacks, and you hope, depending upon how the callbacks are written, that doesn't cause any problems. But in this case, it would lead to the exact same situation still. So it comes back to unless you actually call the remove method on all of the list items, which you can do, you're gonna wind up leaking memory. So this brings me to the first thing that I built kind of on top of Meta.js. And one of them actually, weak map is just an implementation of something in ECMA 6 that isn't in, it's actually in Chrome, believe it or not. I had to disable it for this talk because I wanted to show my version, not the native one. They work the same, but I didn't want to cheat. So the idea with a weak reference is it's an object that upon its creation you pass it a strong reference to another object, and and then it has a method on it, get, and when you call get, it returns a reference to the original object unless the object has been garbage collected, in which case it returns null. So these weak reference objects are really cheap, you can keep them in memory, but most importantly, they break that strong reference link circle craziness so that things can actually be garbage collected. And this allows you to do genuine listening. You can listen to an object, and instead of holding a strong reference to you, that object can hold a weak reference, and then you can be garbage collected even though you're listening, if that makes sense. Which is usually what you want to do when you're listening to something. You don't really care about if you're listening to something, you want to be garbage collected when you're finished. You know what I mean? That's just kind of the semantical meaning, but unfortunately it's not possible to implement in the language. And so this is implemented using kind of the second thing, Oscar the Grouch. So Oscar the Grouch is built on top of Meta.js, and Weak.js is built on top of Oscar the Grouch. And so Oscar the Grouch exposes the non-determinism of the garbage collector to you. So I might have to talk about Meta.js. I kind of did this backwards. Okay, so Meta.js, one of the things that it does, that I've implemented, is it has the ability to get a closure, which doesn't sound that exciting, but it is, it turns out. So inside of JavaScript, when you create function expressions, if the scope is static, at the time that the function expression is created, you know exactly. The interpreter knows exactly which things are going to be in scope based upon the closure. But the problem is there's no semantic way in the language to, after the function has been created, go what's inside of your scope. By holding on to you, what things am I also holding on to? There's emotional baggages. There's an emotional baggage with a function, right? Because when you create it, it could reference all kinds of things inside of its closure. And so you want to be able to see what things that function holds on to. So that's what getClosure does. getClosure allows you to see that. And so with that, I've re-implemented the JavaScript garbage collector inside of JavaScript. And so that's what makes this possible. So it works in conjunction with the native garbage collector. Obviously, it can't actually free resources, but it looks at when things, because the scope is static, it can actually meaningfully look at when things are going in and out of scope, and allow those things to be collected and free for you. So you can do things like so every object is assigned an ID, and if you get an object's ID at any given time, you can pass that ID into getObject by ID, and you get the object back unless it's been garbage collected. You can ask it to let you know. I regrettably implemented this because I talked to people and they were like, this is what made Java bad. But you need it to implement things like weak map. So it also has the ability to let you know after something has been garbage collected. So if something is completely gone, it will let you know that it actually went away. So you can use that to clean things up. And so with that, you can implement things like weak reference, which I described earlier, and weak map. So weak map, it turns out, is probably the more useful of the two, because it solves the second problem I talked about with jQuery. So in a weak map, the keys are required to be objects, and the values can be whatever you want, but the keys have to be objects. And the idea is that as long as you can reference the original object, you're guaranteed to be able to reference the value. But as soon as that the key part of the map, if the only thing holding onto the object is the fact that it's the key in the weak map, it'll go ahead and be collected, which means that the value may be collected depending upon where else you're referencing it. So a really easy way to think about this, and actually the way that most polyfills work is it's like another way of storing information on an object without actually modifying the object, which is really cool. So this is actually another problem I have frequently when I'm developing. I'll have a view and it's passing a model around, and I'll want to store information on the model to give back to another view, and it's like, oh, I can make this weird third object that holds the model and then also holds the additional emotional baggage I want to pass around. And it's uncomfortable. It's so tempting to just put it on the other object, but it's also kind of dirty to just put it on the other object. Weak maps provide an alternative. You don't have to have a third object where you store your data on it, and you also don't have to modify the original object. You can just make the original object a key in the weak reference, store the information, in the weak map, store the information and the value of the key. And you don't have to worry about the jQuery situation of leaking memory when you do that. So that's kind of the high-level overview, and really all I prepared in terms of slides. I guess I'm just going to kind of show it to you at this point. The first thing I want to talk about is performance. When I was making Meta.js, I was really worried about performance, and as it turns out on Chrome, it performs slightly faster than so I should show you what I did. So I took jQuery and I compiled it and I gave it a fairly complicated selector because I was really interested in having Meta.js transform source, how well would it work. And it turns out that it's the same speed or incredibly close, and in some cases it's faster. I have a theory about why it's faster, and I think it has to do with the really aggressive rewriting that I do, because I really do assume that it's statically scoped. And so as a result, a lot of minifiers will just name variables with different letters, and if the variable's just in the closure, it'll use a different letter. But Meta.js, because it's looking for more meaningful information about the scope, actually looks at where the variables are being used to determine whether or not it needs to rewrite it. So as a result, there's a weird side effect of this. So the side effect is that if you create a function inside of a scope and it has several variables inside of its closure, when you call the getClosure method, you won't just get to see everything that was inside of its closure. You'll only get to see the things that it actually referenced inside of its closure. And in the process of doing that rewrite, I think it actually makes it slightly more efficient for JITting. So interestingly, it does add, so it looks like the overhead it adds ultimately gets canceled in the assumptions that it makes about your code, which again are probably safe to do. Unless you're writing really weird stuff, you can probably make these assumptions about your code. So that's that. Let me see. I'll switch it. Okay, so I guess I just want to go to my GitHub page. I'm lame. I need to do more on GitHub, but my name is Alec Larsen. I hope you'll join me on GitHub, and if you like JavaScript, I hope you'll help me build things. I want to build several things. So yeah, please help me. Please help me. I've put together some really bad documentation. It could be documented. Something that can be built. I'm very determined it can be built. Is threads that don't suck. I'm actually working on it right now. It's not at a good enough place to really show you today, but if you're interested, let me know. Let's build threads that don't suck together. There'll be threads that don't suck, and it'll be awesome. So I can talk more about that later. So let's see here. Where is it? Okay, so I guess I'll show the compilation process and kind of how it works. So in this example, I have saveRef and getRef just kind of in whatever scope this happens to run in. I'm going to use them later. And then you can see I have an anonymous function that I'm immediately invoking, which creates a variable called ref. Of course, that variable is only visible inside of the function, but then that function creates two functions. So this ref is the same as that ref, which after this function executes won't be accessible again. However, both save and getRef will be able to reference it because it was inside of their scope at the time of their creation. They enclose it. So if you know JavaScript, that's kind of, just how the language works. So I'll show the process of compiling and kind of what happens. So also, full disclosure, I am the worst compiler writer in the world. It has the worst interface ever. This is another area that you can contribute. I decided just to use streams. So I'm just going to take the input, pipe it in, and the output comes out of standard out. It's very beautiful. Copy this in. I already have a runtime environment running inside of a page, so so inside of this page, the garbage collector, the Meta.js runtime, and Oscar is already running. So I can just run this. That's the compiled version of the code. So now I have saveRef and getRef. They're not exciting. So getRef is going to start out as null because that's what A started out as, or ref started out as inside of here. So what I'm going to do is I'm going to go ahead and create an object. Let's put some data on it. I'll call it A because I'm really creative. Whoops. And then I'm going to hold a weak reference to that object. It's really easy to use. Just get a weak reference. Okay, so now I have a weak reference to that object. Get it? And there's A. This is the side effect of the way that Meta.js has to work, unfortunately. So if you were planning on using __ object ID inside of your application, this might not be the library for you. But otherwise, you should be good to go. So I can call weak reference get, and it's still there. Just to kind of demonstrate a point, I'll destroy. So A was only inside of my global scope. So I'm going to go ahead and destroy my reference to A. So now there's theoretically nowhere, there shouldn't be anywhere else in the application that A can be referenced. And so when I get it, I get null back. Because the weak reference is smart enough to know that, that A has been garbage collected. I should point out that in order to keep Oscar lightweight, this is kind of a best effort thing. Depending upon how fast I did this, it is possible that I could have gotten A back ahead of time. You know what I mean? Because even though it had been freed Oscar had not yet realized that it could be garbage collected, and so the weak reference would still resolve. But that's just, I don't know why that would matter. So don't depend on that functionality if you need to. Eventually, after all references have been destroyed, the weak references will stop resolving, usually within a couple milliseconds. So that's not that exciting of an example. So to kind of show the power, I have the Meta.js compiled code that will actually store this inside of Closure. So to prove that it works, I'll do save ref a, and actually I need a weak ref. Cool, I'm going to weak reference a. Yep. Okay, cool. So now I'm going to destroy the global scope reference to a. So a is gone, and I can still get to A though, because getRef can still get a reference back to A because of that closure thing we talked about. So even though it doesn't look like you can get to A, you still can in kind of, well, the normal JavaScript way. And Oscar is smart enough to handle this. If I do weak reference get, I still get A back. And then if I do set ref, null, what was the name of that function? Thank you. So now when I go back to get weak reference, it's gone. So you can see, as long as the code has been compiled with Meta.js ahead of time, it can do all this. And again, the overhead of compiling with Meta.js is low. At some point, I want to get this into like the asset pipeline with Rails. But again, please help me. Please contribute. I'm one man. One man with a dream. A dream of weak references inside of JavaScript. And so I think that's probably the most exciting thing that I have, as lame as that looks. At this point, but I hope you can see it's demonstratively working weak references. Oh, I know what I can do. Hold on. So OTG is Oscar the Grouch, which is the name of the garbage collector replacement. So it has notify on collected. So hold on, let me project. So I can now, for OTG, cool. So that's A's object ID. So I take that, and I do OTG.notify collected, pass in the object ID. Well, I thought I could pull it off, but I can't. What am I missing here? Does anybody know? Parentheses? Thank you. Okay. So, that's the last. Yep, that's the last reference to A. So I'll destroy this. Woo! Look at that! Oscar called back and knew that the object is about ready to be garbage collected. Yes, this is it. So that's it. So please help me. I'm accepting pull requests. There's still lots of things to be implemented. I really want to do threads that don't suck. I feel like is going to be a bigger deal. It's going to take more than just me, but it'll be really cool. So imagine a world where you can take a Lambda function, ask it to run in another thread, and get a promise back that eventually resolves to its return value. This is the future. This is the future. I think that's it. Thank you.
Anybody have any questions for Alec?
Yeah.
Go ahead.
My knowledge of JavaScript is reactive. What does it look like to do things the right vanilla way, the wrong way, and how do things look better? Like can't do just deregister and that listeners.
Well, so this is
because of that big.
yeah. So you can't. That's the point. But you have to remember to do it. That's what I was getting at. So you're right. As long as you undo every event that you listen for, and you know exactly what times you need to undo them, you're totally fine. But the problem is that you probably don't. Why should you have to remember every event listener that you attach? And it's really, really, really easy, especially with the DOM, to leave event listeners behind. Like, really easy.
What's the pain point that needs to enrage and start this library?
I'm working on a large backbone app that's running an older version, and there's sub-views inside of views, and they have references to things, and memory just flows out from beneath me. It's ridiculous. It's like in the inspector watching the heap size, it's like, where is this memory going? Yeah, I don't know. And I mean, and there's solutions to this. There's inside of the particular project I'm working on, we've kind of implemented this thing that overrides the built-in backbone destroy to like look for sub-views that we may have added. We have like a convention for adding sub-views, and then it makes sure it invokes the remove on every view when you remove the parent view. And it's like, this is too much. This is just, we live in the future. Like, can we eliminate this? You know what it's kind of like? It reminds me of like, I've done a little bit of C, and it's like, you gotta, free things and calc, and it's like, that's what I feel like. You know what I mean? We're in a dynamic language. You should reasonably able to, especially in a language that's so event-centered, be able to listen to something without having to keep in mind that because you listen to it, the thing that's listening can no longer be garbage collected. Not for every use case, but I think for a lot.
Any other questions